Okay, so today we're going to talk about exponential functions. Looking at this top up here, exponential functions are written in the form the f of x equals a times b to the x, with x being our exponent. The first thing I want to talk about, we're going to move over here, is how to graph an exponential function. So if they give us f of x equals 3x, 3 to the x, remember f of x and y are somewhat interchangeable, so we can start with that. So now we have y equals 3 to the x. We can pick any x value if we're just graphing to plug in for x to get an ordered pair. Those ordered pairs will help us graph our exponential function. They also might give you a number like over here where they give us the f of 2. If they give us the f of 2, then we're plugging 2 in for x. So 3 squared is 9. So we have y equals 9. Because f is 2 and y is 9, then we can make them an ordered pair. Now we have 2, 9. Now we can plug in another number. We can plug in 3. Do 3 cubed. What we get for y. We plug that into an ordered pair. Now we can graph these points, do some positive, some negative, and that's going to give us the shape of our exponential function to draw our slight curve through. So if they give us just the function, we can plug these numbers in, pick any x value to plug in for x, solve for y, and that gives us ordered pairs to graph it. We can also take an f of x, take anything they give us for x, plug that in for x in our function, and solve. The next thing we're going to talk about is the graphs themselves. The basic and first things we need to remember are we need to focus on looking at this letter B up here. So B is going to determine what happens to our graph. First, we need to look at B and see if it's greater than 1 or if it's between 0 and 1. For these over here where B is greater than 1, this is the shape of our graph. If it's a positive B, then we're making this shape where it rises to the right. If it's B is greater than 1, but we have a negative in front of our AB, then it's going to fall to the right. If we have a number, it's typically going to be a fraction between 0 and 1, like 1/3, then it's going to rise to the left. If we have a negative 1/3, then we're going to fall to the left. Looking down here at our formula, we have y equals a times b to the x plus c. B, we know, is telling us what we're doing with our graph, the way it looks. A is our y-intercept. So that's where it's crossing the graph. So we could, if they were giving us an equation, we could use what A was and see if it crossed the graph at that point. If it did, then that would help us identify the graph that we're looking for. Say we have something that looks like this. Y equals 5 times 3 to the x plus 1. So we're looking for something that intercepts the y-axis at 5. Then we're looking at 3x. Is that a number greater than 1 or between 0 and 1? Since it's greater than 1, we know that we're going to use this up here. It's going to look like this graph, but it's going to intercept up here at 5. The other thing we're looking at is this number 1. So this number 1 over here determines where the line is. So up here, this line right here, this dashed green line, is at 0. So if it was up 1 and the positive 1, then that would be keeping the function above that. So that would be determined by this line. So those are all different things that you can look for that can help you identify the function if we were matching it or trying to put together its graph. Lastly, we're going to look over here at domain and range. So everything that you need to know for this particular chapter, this particular section of this book, is just that the domain, which is our x values, is always going to be all real numbers. Because either of these functions could go all the way to the right, all the way to the left, on the x-axis, and any of those would be included in it. The alternative one is the range, which is the y. For this green line right here that we're looking at, we have y is greater than 0 for this positive one. That's going to be our range. Y is greater than 0 or all positive real numbers. For that bottom function, it's going to be y is less than 0 or all negative real numbers because of that line being 0. If we move that line up like we were talking about to that positive 1, right? And then our line kind of went like this under it. Then our y, our range, would be y is less than 1. Because that would be moving our range to where that line is. So again, our y-intercept, the first thing I encourage you to look at when you're looking at things is this line. Because this line is going to help you figure out what this c is. Then look for b. Is it a fraction? Is it a whole number? Because that helps you determine where and how we graph our line. And then lastly, our y-intercept. And remember, our y-intercept goes up from this C line because that becomes our new 0. So if our line's here at 1, we're going to go up 5 from there for this particular problem. And then it would go on from there.